All right, so to start this problem, I would first start by drawing it. Because I have 5 minutes, I'm going to move through this like a little bit quickly. So we know that at the very beginning, ship A is 10 nautical miles west. So I'm going to assume that like I'm going to use this as 0, 0, and I'm going to make a point here. So it's starting at -10. And then we know that this is going to be my starting spot of A, and this is at noon. And then this is going to be my original starting spot of B. So for A, we know that with respect to time, A is going to move, this is going to be equivalent to 15 knots. And then for B, in respect to time, B moves 17 knots. So then the question is asking us, hey, at 5 o'clock, which is going to be 5 hours from this initial picture that I just drew here, what is that distance? Like, how is that changing? What's that rate? So just by going through here for the location of A, we are going to have 5 hours and it's moving at a rate of 15 nautical miles per hour. But we also have, and it's going west. So I'm going to make this a -15 because it's going to continue to the left here. And then I also need to make sure I account for the -10 that it's already existing at that initial starting west spot. And then that's going to give me an answer. And then for B, B is going to continue upwards. And then, sorry, A is going to continue west and it's going to continue north. So then for B, whoops, oh my goodness. So then for B, that rate, we know that B is going to be moving positive upwards. So I'm going to keep that as a positive number at 17 knots. And because it started at 0, 0, I don't need an additional number there. And this is 5 because from noon to 5 p.m., that's 5 hours. So this is hours, this is hours. And then our -15, I have that negative because it's going left to the west. It's just based on how I drew my image. And then this is our rate of change. That's why we have those numbers. So then once we do that, 5 times 15 is 75. But then we have the -10. So this is going to be -85. And then 5 times 17 is going to be also 85. And then from there, we can then figure out that we know that our new points after our 5 hours, this point up here is going to be 0, 85. And then the number that's going to be far to the left for A at 5 p.m. is going to be -85, 0. So now the next thing we need to do is find the distance between these 2 points. So by doing that, we can just use our distance formula, which is the square root of our x2 minus x1 squared plus y2 minus y1, and that gets squared. Friendly reminder that the square root is applying to, it's like this, it's applying to everything underneath here. It's not a very pretty square root. So then once I plug everything in, I say it's the square root. This is my distance is equal to, I'm going to do, whoops, 0. It's going to be minus, but it's a -85. And then that's going to get squared. So this is going to become a plus. Oh, whoops. Square root. And then we're going to add that to, whoops. And then 85 minus 0 squared. And then once we do all of that out, you are then going to get the distance there. I'm just going to say that's going to equal, let's just make up a number or a letter. We'll just say we'll just say D. I'm running out of time, so I'm going to put the rest of this either in another video if I can, or I'll finish it in the notes below.